I'm sure that you guys have started covering stuff like insurance, expected utility, probably some like consumer surplus, supplier surplus stuff. I'm gonna hold off on that until next week. So it may be crammed next week, but I really think that it's good to emphasize maybe practice problems for you guys. So that's what we're gonna do for today. We're just gonna go over old midterm twos, and we're gonna ignore some of the questions that have to do with stuff that won't be on the midterm, so like expected utility, insurance, and all that. Um, but before we get started, does anybody have any questions? Um, Maybe any like things that are concerning you about like material wise or anything like that. Um, and if there's not, then we can definitely just go ahead and get started. All right. So it looks like there's no questions. So the first midterm that I'm going to work on is going to be midterm 2 from fall 2018. So if you guys want to go ahead and pull that up, I think that, so midterm 2, fall 2018. I think that this is a good place to start. All right, and let me pull it up. Oops. All right. So let's go ahead and get started. Let's go on to question 1, right? So question 1 is asking us about the substitution and income effect for a perfect complement situation. So utility of x1, x2 is equal to the min of x1 and 2x2, right? So if you were to graph this out, basically you need 2 of x1 for every 1 of x2 to be on the indifference curve. So something like this, 2, 1, 4, 2, right? These are just examples of the indifference curves that we have. And so when we're given the information, right, we know that we're currently consuming on a corner, right, one of these king points. And so if I were to actually draw it to scale, I might want to rework kind of this stuff here. So what you can do is you can actually either work through the question and solve it numerically because you are given enough information to do so. I don't think that's really necessary. I think that more of a intuitive kind of knowing how to go through these problems conceptually, right, is going to be more beneficial. So let's just assume that this is going to be the optimal point that we're consuming at. Just kind of ignore the fact that I'm dealing with numbers that aren't what's given in the problem. I think I want you guys to just pay attention to what's going on in the diagram. So we're currently consuming here. This is our point A. And we're given that the price of commodity 1 increases from 1 to 2, meaning that our budget constraint is going to shift inwards like this, right? And we're going to get a new point C. That's right over here, right? It's going to be on a lower indifference curve. The thing about substitution and income effect, right, if you remember, is that when we're finding point B, we know that the slope of point B is the same as the slope of point C, and that the utility at point A is the same as the utility at point B, which means that it has to be on this indifference curve, and it also has to have this new slope that we have, right, which is steeper because of the price increase. So as a result, we know that because we're dealing with perfect complements, the optimal bundle is always going to be at these corner solutions, which means that just generally for all perfect complements, we're going to have that point A and point B are going to be at the same place, which implies that the substitution effect is 0 and the income effect is negative, right? Because in this case, the income effect is the total effect, right? Um, yeah. Does that make sense to everybody? Are there any questions about that? I think that's kind of just a cool thing to know just generally about perfect complements.
How
Uh,
did you draw the graph for when you put the point C? How did you draw that graph?
so with point C, I know that because there's a price increase, that means that my budget constraint is going to pivot inwards, right? Meaning that I can no longer afford as much X1 as I previously was able to afford. And so that means that in order for to find point C, it's got to be on this new budget constraint, which is just generally lower, right, um, than these new indifference curves, if that
Okay,
makes
thank
sense.
you. Yeah, that makes sense now.
Yeah, and so Becky, to answer your question, for perfect complements, yeah, the substitution effect, from what I've seen, is always zero. I think it makes sense that they're always zero because we have these exact king points. But for just general complements, so like not perfect complements, that won't always be the case. Yeah. So I believe that kind of covers this question pretty thoroughly. Um, if there's any more questions, go ahead and feel free to ask. Otherwise, we're probably just going to move on. All right. So seems like there's
Just
no
real
more
quick,
questions.
was this substitution effect always zero for substitutes?
For substitutes, so
Yeah.
let's actually take a look at that. And this is going to be something
Or
that,
I meant complements, but yeah.
for perfect complements, yeah, they're always going to be, the substitution effect always going to be zero.
Okay.
I'm trying to think if we can make that same extrapolation for perfect substitutes. I haven't done one of these problems in a while, but I think uh, I've seen a problem where for perfect substitutes, the income effect wasn't zero, which is what you would assume. But actually, let me just kind of rework through a problem. So this is not going to be on midterm 2, fall 2018. This is just me coming up with a problem kind of off the top of my head. So let's just say that utility is equal to x1 plus x2, and that p1 equals 1, p2 equals 2, m equals 10. So let's say, right, x1 and x2 right here. This will be 10, and this will be 5. Right, so we have a budget constraint that looks like that. And my indifference curves, right, MRS is just going to equal to 1. And so this slope is equal to 1/2, or I guess negative 1/2. And the MRS is negative 1, which means that the slope of my, and I'm going to use a different color, the slope of my MRS is going to be greater than the slope of my budget constraint, meaning that we're originally consuming here. So this is point A. Okay. And let's say that the price of good 1 changes from 1 to 2. We want to see what the substitution and income effect are, right? So we now have a new budget constraint that is actually going to be this slope right here. So maybe I'll just kind of erase that right here. So we now have a new budget constraint, right? But you'll notice that the slope of our MRS is now going to be the slope of our budget constraint, right? Which means that by substitution and income effect, or by substitution effect, we know that it's got to have the same utility, right? Which means it has to be on this same indifference curve, right? And so here, basically utility of A equals utility of B slope C equals slope of B, right? So we know that the total effect, right, what's ultimately going to happen is that we're going to be able to consume anywhere along this curve right here. So we can consume anywhere between 5, 0 and 0, 5. So maybe this isn't the best problem to work through, but we're just going to give it a go. Does everybody understand why we're going to be able to consume anywhere on this line, by the way? Right? Hopefully you guys should be familiar with that, and that's because the MRS has the same slope as the budget constraint. So that's going to be like the total effect, what's ultimately going to be our point C. So let's just say point C is right here, for example. Okay? That means that the slope, right, of our point B has to be the same as our point C, which means that it has to have a slope that is -1, which it already was before. And it also means that it has to be on A, right, on the same indifference curve as point A, right? And so that tells us that our point B, and I'm not sure if I'm interpreting this correctly, but I feel like our point B could be anywhere on this curve, right? And I know that I'm actually probably confusing you guys at this point because of all the different possibilities for points to be. But if you just go by these general rules, right, it would make sense that point B is anywhere here. So as a result, you wouldn't have it that the substitution effect or the income effect, right? So the reason I bring this up is because we have it as a rule that the substitution effect for perfect complements is always 0, right? And so you would maybe infer from that that the income effect for perfect substitutes is always 0. But I think that this right here, if anything, that I've shown you is just a counter example to that, showing that the income effect doesn't always have to be 0, right? Because of kind of instances like this where going from point B, which if we just say our point B is right here, for example, right? This would yield different results. And so I probably confused you guys more than I've helped you guys, but are you guys able to kind of understand what I'm saying, that the substitution effect for, or that the income effect for perfect substitutes isn't always 0? I think that was probably like the main point of what I was trying to say, but I picked a problem with weird numbers. So yeah, maybe we can do this over with different numbers, just so that I don't leave you guys more confused than I already have. So let's keep the same MRS, right? We're going to keep the same original situation. So right here, right here. We're currently consuming here. This is our point A because we have indifference curve like this. And let's say that instead, price of good 2 goes from 2 to 3, right? Which means that we're now going to have a pivot inwards. So this is like 3-ish. And so what you're going to see is that basically we were already consuming all of good 1 to begin with. And that means that the total effect is that we're going to be consuming all of good 1 anyways at the very end, right? So if you were to chart this out, the total effect is going to be 0, right? And so you want to see, right, basically it has to have the same utility as this indifference curve, but it also has to have the same slope, right, as this curve right here. And so what you'll see is that, will it be 0, 0? All right. This is actually something that's more confusing to me than I realized. But I think I wouldn't worry too much about this because I don't see those a lot occur. And I think that the intuition behind it is simply that just because you can say that for perfect complements, the substitution effect is 0, that you can't say that for perfect substitutes. So that's like the main thing. And I think that if you see a problem, it'll probably give you like more workable numbers to kind of do your calculations for. So in that instance, it may be easier to see. I'll actually get back to you guys. I'll maybe send out an email later today with a worked out problem. But actually for now, I think that it would probably be more beneficial if we just moved on through the midterm. All right. We're going to skip number 2 because it has to deal with insurance. And we're going to go straight to number 3. Okay. And so the way that you want to work out number 3 is to kind of interpret what these words are saying about our nominal interest rate and what they're saying about our inflation, right? So it's one of those problems. So Ryan, I don't believe there's going to be any insurance questions on your midterm. Expected utility, I believe, wasn't covered on, yeah, it should end on like the intertemporal budget constraint stuff and like investing. Yeah, no worries. So going to question 3, this is one of those situations where your nominal interest rate and your nominal, or I guess your just inflation rate, are given to you implicitly in that they don't tell you exactly what the rates are, but you're supposed to read into the question and determine it. So we know that the price of a hamburger this year is $60, and we're given that. So let's just look at P1 is equal to 6, M is equal to 60. Right, we're just writing stuff down. If he puts money into a bank account that earns 5% over the next year, how many burgers can he buy after 1 year if the annual inflation rate is always 50%? So we've just been given that pi is equal to 0.5, right? And we're given that R is equal to 0.05, right? Because it says that a bank account would earn 5%. So we have it that he currently has $60, and we want to see how many hamburgers is he able to afford after 1 year if the inflation rate is always 50%. So you assume that his $60, right, is going to be moved into period 2, right? So 60 times 1.05. So let's just do that real quick. Nine. Oops. 0, 0, 3. Or oops, this is 0, 3, 6. So $6.30 approximately, or $63. Wow, that was really bad math. I apologize, guys. So he's going to have approximately $63 in period 2. And we're given that the inflation rate is 50%, meaning that P2 minus 6 over 6 is equal to 50%, right? So 0.5, right? So you multiply this by 6, P2 minus 6 is equal to 3, so that P2 is equal to 9. So basically, if the inflation rate is 50%, a burger in period 2 will equal to 9, right? And so because we're only interested in how many hamburgers he can buy, right, we're going to say that he has $63 in period 2 and a burger costs $9, which is why he'll be able to afford seven hamburgers, right? So yeah, I probably made that harder on myself.
How did you use P2 minus 6 over 6?
Well, so this is just general like change in price to find a rate. So this is kind of like the thinking of new minus old over old. That'll give you the rate in which you're increasing, if that makes sense, or decreasing. So basically, in order to find this 50%, you would set up this equation. Another way of doing it is just doing 6 times 1.5, right, is equal to 9. Both methods work. It's just kind of whatever you prefer. But this is basically just to find what the new price is given that 6 increases by 50%.
Okay, so that P2 is not saying that that's the price of good 2. That's the
No,
price
that's like
in the
price
future.
that's like price in period 2.
Price of period 2. Okay.
Yeah. Sorry for the lack of clarification. Okay. So moving on, let's go to question 4. Let's go to question 4. This is like a buying and selling question because we're given an endowment. So the endowment of apples is equal to 6. The endowment of oranges is equal to 8. The price of apples is equal to 2. Price of oranges is equal to 1, right? And so he has 1-to-1 perfect substitute preferences, which means that utility is equal to A plus O, right? Meaning that he prefers them equally. They both give the same utility to him. And so how many oranges will she consume in order to maximize utility? Well, we're gonna be interested in this equation, P1 x1 plus P2 x2 equals to M is equal to endowment 1 P1 plus endowment 2 P2. And in this case, I wrote P1 as being the price of apples and x1
There's
as
a
being
glare on the whiteboard.
Oh, is that better?
Yeah, it's better. Thank you.
Yeah, sorry. So essentially what we do, and I think that you guys should do this with all endowment questions, is just calculate what kind of income the endowment brings. So in this case, we have it that 6 times 2 plus 8 times 1, right, is the level of income that we're going to be able to produce, right? This is equal to 20. And so this is simply just a perfect subs question where we want to measure the MRS relative to our price ratio. So we have apples here, oranges here. We're going to be able to afford 10 apples and 20 oranges, right? So here's our budget constraint. And we know that our slope of our MRS is just going to be 1, meaning that it'll look something like this. And so that tells us that we're going to prefer to consume oranges and only oranges, which means that oranges is equal to 20. Okay? And I think that these questions are pretty straightforward as long as you're able to recognize what the purpose of the endowment is. And just to kind of remind you, the value of the endowment is what's going to determine your utility, right? because it controls like at what point your indifference curves hit your budget constraints, right? So basically, if the value of your endowment goes up, your utility goes up, and if the value of your endowment goes down, your utility will go down as well. Okay. So let's move on.
Real quick on that, Eric.
Yeah.
Can you like walk me through why you drew the second like line on that graph? Like I understand it's like the slope moving up, but it's like, do you really even necessarily need that? Because you have to figure out the 20s.
No, you don't. I mean, you don't need it. It's more for just like a visual effect. But I like to draw it because it shows you what the slope of your indifference curves, which I'm going to draw in green, right? We know that we have infinitely many indifference curves. So this is just an example of one indifference curve. And this is just an example of a second indifference curve, right? They both have a slope of -1. But you see that the point of intersection with the highest indifference curve is here as opposed to here, right?
Yeah. No,
Being
yeah,
here puts us on a higher indifference curve. So that's kind of just why I draw it. Okay. Let's move on. We're gonna skip number 5 because it's a consumer surplus question. And we're also gonna skip number 6. So we're going to move on to number 7 and try to work that one out. So number 7, his utility is equal to R times C squared. And we're given that M is equal to 600. L bar is equal to 90. Price of consumption is 1, right, which we've already established. Hourly wage rate, W, is equal to 10. And so the question is, what is R, right? And what is C, right? So actually, no, not what is R. How much will he work? So how much he works is actually L, right? So that's kind of tricky. You want to be really careful that you're answering for the right variable. So yeah, just kind of a warning there. So when I am working with a question like this, I think that it's a good idea to draw out your budget constraint. We know that the maximum amount of relaxation that this person will consume is equal to the amount of hours that he or she has in a week, which is equal to 90, right? We know that because this person has a non-wage income, they're going to have a point that looks something like this, right? Where even when they're not working, they're going to be able to consume $600 worth of consumption. And we also want to find this intercept, which is M plus WL bar, which in this case is equal to 1500, right? And if you're wondering how I got 1500, that's simply 600 plus 90 times 10, which is the total amount of income that is possible if he works for every hour that he can, which is 90. So you get a downward sloping curve like that, and the slope of this is going to be -10. Right, so this point is 90, 600. And so let's kind of go through the step-by-step process of these labor leisure questions. So we're being asked, what is L, right? And what is C? So we know that L bar is equal to R plus L, right? And so we know that basically R plus L is equal to 90. So that tells us that if we solve for R first, that'll be able to kind of reveal to us what L is there. So let's go ahead and get started. I think that a good first place to start is to just find my MRS. right? Which in this case is going to be C over 2R, right? So yeah, so C over 2R is my MRS. And I want to see if I have DMRS, right? Because we need that in order to establish an interior solution, right? As opposed to corner solutions. So when R goes up, my MRS is going to go down. So I've established this. And I'm going to set this equal to my price ratio, which is equal to 10, right? And if you want it to be negative 10, then you just need to make your MRS negative. Either way, they're going to cancel out. So we get that C over 2R is equal to 10. I think that it'll be good to solve for C. So C is equal to 20R, right? And we're going to need our budget constraint as well. So we have P times C plus WR is equal to M plus WL bar, right? And let me actually shift this right here so that we can see it better. This is 90, 600. So we now have our budget constraint and we have what C is, right? So in this situation, we have P, which is 1, times C, which is 20R. So we have 20R plus W is 10 plus 10R is equal to M, which is 600, plus W, which is 10, times L bar, which is 90, right? And we already established from this point right here that this is all equal to 1500, right? And so we have that 30R is equal to 1500, which means that R is going to be equal to 50, right? But we're not interested in what R is, right? We're interested in what L is, right? So because R, which is my leisure, is equal to 50, that means that I'm going to be working 40, right? And so if I'm working 40 hours, we're going to be able to determine how much I'm able to consume, right? We know that our consumption is equal to M plus WL, which is our non-wage income, plus the wage times however many hours we work, right? And so in this case, this is equal to 600 plus 10 times 40, which means that our consumption is going to be equal to 1,000, right? And so we've solved for both of the questions that were being asked. And so, yeah.
Hey, isn't it on the step where we factored out R? Isn't that value 30R? Right?
30R equals 1500.
Oh, okay, and then R is 50. Oh, I misread it. Okay, great.
Yeah,
Thank
so you just divide. Yeah, maybe this was a little bit confusing right here, but you just divide by 30 on both sides.
What happened to the PC thing?
So because we've established that P is equal to 1, you can pretty much just treat it as like this. And we've already found that C is equal to 20R. So this is where it shows up right here.
And where did you establish that P equals 1?
Well, it's given in the question, so the price of consumption is set to 1. But just generally speaking, you're going to be able to make that assumption that P is equal to 1 because we consider consumption like a composite good, because it's not like very defined what specifically you're buying. So I guess in this case, consumption is like food, clothes, restaurants, I don't know, movies. So it's not defined what specific good you're working with. So when we don't know what the good is, like when it's not defined for us, we just set the price equal to 1. All right. Are there any questions about this?
I have a question.
Yeah, what's up?
You have that 10 equals R plus L at the top, and then you say that R is 50. So shouldn't that mean that 10 equals 50 plus L? Shouldn't L be negative?
Oh, this is a 90. Sorry.
Oh. That makes way more sense. Thank you.
Yeah, that's a 90.
All good.
So
Yeah.
we're also finding consumption, right? So we can just use that C equals 20R, plug in R.
Yeah. Actually, you could do that. I didn't even think about that. So, that's a good point that got brought up. If you don't want to, or if you're just not familiar with this equation right here, which I hopefully you are, but even if you're not, because we know that C is equal to 20R, and we found what R is, we can actually just plug in 50 into here and get 20 times 50, which produces the same value of 1,000. All right. Any other questions? Let me see the chat. Yeah. So, I'm going to move on to a new midterm. If you guys want to keep following along, I'm thinking that I'll just do the next fall, which is fall 2019, and go through as many problems as those as possible. Are there any like specific concepts that you guys are confused about that you maybe want me to answer, as opposed to going over practice problems? I'll take that as a no.
Can you kind of review over like what's the thinking behind a substitution effect and then an income effect? And like
Yeah.
Yeah,
So,
I'm kind of getting caught up on like calculating the SEIE or just anything to do with either of those would help.
Me too. I feel like the problem is when there are like concrete numbers, because I can do it conceptually, but if it asks for like a specific number, that's where I have problems.
Yeah, the numeric.
Right. Yeah.
okay, so you guys are struggling when it's numeric?
Yes.
Yeah.
Okay, yeah, I could
could
definitely.
you also explain it conceptually for me too? Because that's kind of where I struggle.
Yeah, sure. Let me see if I can find one that deals with perfect substitution, or not perfect but a substitution effect and income effect. I'm on fall 2019. I don't see anything, so maybe I'll just.
Spring 2015, number 5 is a good example, I think.
Spring 2015. Okay, number 5, you said?
Yeah.
Yeah, okay. So
Yeah, that's like what I'm having problems with.
we'll just actually, let's walk through this problem then. So this is question number 5 from spring 2015. Let's write down our information. P1 is equal to 1. And P2 equals to 2. M is equal to 24. And we're given that the price of good 2 increases to 4. So going from 2 to 4. Right. So let's take a look at what the utility function is, right? So the utility function, geez, this pen is dying. The utility function is equal to the min of x1 comma 2 x2, okay? So we know that we're going to have perfect complements here. And so that's already going to kind of give us a clue as to what the substitution and income effect is. But let's work through these and get like numerical answers. The substitution effect, income effect, total effect, right? And let's draw this out on a graph. Let's say that x1 and x2 are here, right? This will be 24, and this will be 12, right? And so before anything happens, we want to find where point A is, right? And so we know that point A is going to be just the original optimal point. And so this will be kind of like week 1 to week 3 stuff, where we're just going to set these middles equal to each other. So x1 is equal to 2x2, right? This is the ratio between the two that we need in order for basically to keep the middles equal to each other. And so that was maybe a little bit redundant, but you see how this is essentially saying that for every x2, right, we're going to need 2x1, right? And so that's kind of, if you were to plug these in, we would get the same number, right? And so this already tells us what the relationship is between x1 and x2. So we can actually plug this into our budget constraint straight away. And so we get P1, which is just 1, times x1, which is 2x2. So P1 x1 plus P, whoops, P, what the hell? P2 x2 is equal to m, right? P1 is 1 and x1 is 2x2. So we'll get 2x2 plus 2x2 is equal to 24, right? So 4x2 equals 24, which means that x2 is equal to 6, right? Which means that x1 is equal to 12, right? And so our original point, come on, let's just do this in the green. Our original point A is going to be 12, 6, right? So that we have something that looks like this. Okay, and so we've found what point A is, but I think that it's going to be useful, right? And I've said this before, to find point C before we find point B, right? And so point C is going to be on the new budget constraint, which if you look at it, right, it'll still be 24 here, but it'll be 6 right over here. And I apologize if it's hard to see. I know that there's glare and these markers aren't great. So 6. Right, we know that point C is going to have to be on this, this new budget constraint. So we're going to keep the same relationship, right? The MRS doesn't change, or I guess the utility function doesn't change. And so we know that for every 1x2, we're still going to need 2x1s. Just that we're going to be plugging it into a different budget constraint, right? So P1 is still 1, right? So P1 x1 plus P2 x2 is equal to m. So P1 stays the same and x1 stays the same. So this is 2x2. But now we have it that P2 is 4. So we have 4x2 is equal to m, right? Which we know is already 24. So we have 6x2 is 24, which means that x2 is equal to 4, right? And when x2 is equal to 4, that means that x1 is equal to 8, right? So this was 12, 6. So, right? And we know that this is now going to be 8, 4, which will be right here. Okay? And so we now have what our income, like what A to C is. And so I'm trying to think if there's like a right way of solving for B. So this is 8, 4. I'm trying to think if there's a right way for solving for B. We know that conceptually, point B is going to be on this indifference curve, right? This original graph, or this original curve. We also know that it's going to have the same exact slope as we did before, right? But because we're not dealing with like a continuous function, we can't really apply calculus to this. And we're simply going to have to use our intuition, right? What we already know about perfect complements in order to solve this, right? So with perfect complements, we know that our budget constraint, right? I guess if you will have to be parallel to this new budget constraint. And so that's actually going to intersect at a point that looks like this, right? Where A and B are the same, right? And this is like the new slope, if you will, where B lays on, right? Which is the same slope as point C. Does that make sense? Because we're assuming that we're keeping utility the same, right? So there's not as much math for finding point B. So you're going to have to use intuition, as I said before. But that tells us that the substitution effects going from A to B, right? If you remember, so this is A to B, this is B to C, and this is A to C, right? Going from A to B, there's going to be 0 substitution effects. Going from B to C, right, we're going to have -4 and -2, right? Which means that the total effect is -4 and -2, right? For x1 and x2 respectively.
Can you explain how you got B again on the graphing?
Yeah, I'll try my best because it's hard to explain when you're not like writing equations down, I think. But based on what we know about the substitution and income effect, right, we know that the utility at point A has to be the utility at point B, and that the slope at point C has to be the slope of point B, right? But because we're dealing with a L-shaped curve that looks like this, where we have a kink, right? It means that we're going to have to optimize for B, right, at this corner solution anyways, right? And that kind of holds true, is that for any optimization of a perfect complement, it's always going to be at the corner point, right here. And so no matter what the slope is, we know that if it has this utility, that the point B is going to be right here at the same point as point A, right? And so this blue line, which, I mean, it might be hard to tell that it's blue, but this line that I've drawn right here that kind of runs this way has the same exact slope as point C, right? Meaning that it has the same budget constraint, or not the same budget constraint, but the same price ratio, right? Which is 1/4. And so that's kind of how you go about it. It's not as a smooth process as Cobb-Douglas, right? There's definitely some like assumptions that you have to make. But if you remember, we did a problem in the original midterm that I was covering where we already established that the substitution effect for perfect complements will always be 0. And so that's kind of what leads you to be able to come up with this point, right? If the substitution effect is 0 for both x1 and x2, that means that going from A to B, there has to be no movement, right? Does that make sense?
Yeah. The only thing is, isn't the 0.84 below that second budget constraint, like on the graph? Would it be
So the
below?
0.84 is on the new budget constraint, which is where my point C is.
Oh, okay.
Right, and we know that point C is where we're, so point A is maximizing with the original conditions, and point C is maximizing with the new conditions, right? And so that's all I've really done. It's just I maximize my utility with the new budget constraint.
Okay.
For the income effect on your IE right there, we subtracted, or you subtracted 8 from 6 from 8, right?
No, I did 8 minus 12, and I did
oh yeah,
4 minus 6.
4 minus 6. Okay, yeah, I got you. Thank you.
Yeah, no worries. Are there any other questions? I know that perfect complements is a bit of like a niche one, but does anybody want me to do a Cobb-Douglas just real quickly?
Yeah, that was great.
Oh, yeah.
Yeah. Okay. So this is what you're more likely to see on a test is a Cobb-Douglas. So let's just kind of come up with a question that on our own. So let's say that utility. Oh my God, that is so light. Let's say that utility is equal to x1 squared x2 to the 5th, right? Just for example. And let's say that P1 is equal to 2, P2 is equal to 4, M is equal to 40, right? And we say that P1 changes in price from 2 to 4, okay? So we draw this out, right? We know that our original budget constraint, So x1, x2 right here will look something like 20 and 10, right? Where we're able to afford 10 units of good 2 and 20 units of good 1 if we don't buy any of the other good. So this is our original budget constraint. And we get it that P1 is going to increase in price and go from 2 to 4, which means that I'm now, right, going to have a budget constraint that looks like this. So let's go through and figure out how to solve this. So the first step is always going to be to find the MRS, right? So MRS in this case, if you use the trick that I taught you guys, is just going to be 2 x2 right here, over 5 x1, right? And then from here, right, we know that we have DMRS just because you can kind of do the test on your own. But that's going to allow us to solve or set it equal to our price ratio in order to find point A, right? So 2x2 over 5x1 is going to be equal to 1 or 2 over 4, which is just going to be equal to 1 over 2. And so I get that 4x2 is equal to 5x1. And let's just solve for x2 first. x2 is equal to 5x1 divided by 4. And I'll plug this into my budget constraint in order to solve for my variables, right? And just as an FYI, if you guys want to go, you guys are totally free to. It's already past 150. But this is just for whoever wants to kind of stick around. So P1, so P1 x1 plus P2 x2 is equal to M, right? P1 is 2, x1 is just x1, plus 4, which is P2, and this is 5 x1 over 4 is going to be equal to 40, right? Which means that 2x1 plus 5x1 is equal to 40, which means that 7x1 is equal to 40. So that x1 is equal to 40 over 7, right? And you'll notice that these are not like whole round like numbers. So these are fractions, which makes it a little bit more difficult. But if you plug this into x2 equals to 5x1 over 4, what you'll get is 5 times 40 over 7, right, which is 200 over 7. So 200 over 7 divided by 4, right, is going to be 200 divided by 28, 100 over 14, so 50 over 7, right? And I'm kind of just going through these calculations pretty quickly, but I'm basically just solving for x2 now. So I have that point A is going to be equal to 40 over 7, comma 50 over 7. All right. And so now I found what point A is. So let's think about where that is, just generally. 40 over 7 is going to be roughly 5-ish. And 50 over 7 is going to be roughly 7-ish. So this is 10 right here. So 5, 7. This is going to be my original point A. All right, now let's solve for point C. We're going to do the same exact thing where we have 2x2 over 5x1. This is my MRS, right? That doesn't change throughout the problem. And we know that we have DMRS, so we can set it equal to a price ratio. In this case, the price ratio is 4 over 4, which is just going to be equal to 1. And so I get that 2x2 is equal to 5x1. And so x2 is equal to 5x1 over 2, right? Using the same price rate or same budget constraint equation, I'm going to find that P1 is 4. So 4 times x1 plus 4, right? P2 is still 4. 4x2, and we have that x2 is equal to this. So 5x1 over 2 is equal to 40, right? The 4 and the 2 are going to cancel out so that I get 10. And so I get 4x1 plus 10x1 is equal to 40. So that 14x1 is equal to 40. X1 is going to be equal to 40 over 14, which is equal to 20 over 7. And x2 as a result is going to be equal to, let's see, 100 over 7 divided by 2 is equal to 100 over 14, which is 50 over 7, right? So my value of x2 is actually not going to change, but I see that my value of x1 does change, right? So 20 over 7 is about 3. So that tells us that our point C is going to be somewhere around here. Right? Let's take a look. Yeah, I did that right. 20 over 7, 100 over 7, 100 over 4, yeah. Okay. So we found what point A and point C are, but finding point B is what's really going to be a bit challenging, right? So we know that the utility at point A has to be equal to the utility at point B, right? And that the slope at point B, or slope of point B has to be equal to the slope at point C, right? And so if you take that information into account, we know that because the slope at point C is steeper than the slope at point A, and because we know these are Cobb-Douglas, and so they have diminishing marginal rate of substitution, that in order to have a point that's tangent to my indifference curve, it's going to have to be to the left of A, right? Simply because we know that the slope here is greater than the slope here, right? So I kind of sketch my new, and actually this is kind of not very curved. Right, I'm going to draw my new, if you want to call it, I forgot what they call it in the book or on the notes, but this is like the point that's tangent to the original indifference curve. All right, that won't show up. I'll try to get new markers for you guys. I just haven't wanted to yet. Right, and so that tells us that point B is going to be somewhere here, right? But we don't know the exact value of point B, like we know the exact value of point A and point C, right? So just a reminder, point C was 20 over 7 divided by 50, and 57. So these are the coordinates, and these are the coordinates, right? We know that point B just kind of intuitively has to be to the left of A, right? And that's, again, a reminder because of the fact that the slope at point C is equal to the slope at point C, or slope at point C is equal to the slope at point B, which means that the slope has to be higher at point A, or at point B than it is at point A, which means that it has to be higher on the indifference curve. So that's kind of why, right? But we also know that, right, because the slope at point B has the same price ratio as the slope at point C, right? I'm going to have 2x2 over 5x1, and I'm going to have this equal to 1, right? Because this is my MRS, right? And this is the slope, right? So if you guys remember, the MRS is just the slope of my indifference curve at a specific point. And so I'm going to set this equal to 1, right? So I want to find where on this indifference curve the slope is equal to 1, right? And so just rearranging, I get 2x2 is equal to 5x1, so that x2 is equal to 5x1 over 2, right? And this is where the calculations get a little bit funky, because I need to plug these values in to my utility function. So the utility at point A is going to be 40 over 7 squared times 50 over 7 squared, right? Which is equal to about 1600 over 49 times 2500 over 49, right? You can see how these are like not really easy numbers to work with. But that's just kind of what they are. So the utility is equal to 1600 times 2500 over 49 squared, right? And what I'm going to be able to do is substitute this value of x2 into here and get that x1 squared times 5x1 over 2 squared is going to be equal to this value right here over 49 squared, right? And it's going to be really kind of messy, but hopefully you guys can see how, right? And so, right, hopefully you guys can see how, because we only have one unknown variable, we're going to be able to solve for x1 by kind of just working through it algebraically. So x1 squared, 25, x1 squared over 4, right? This will just be multiplied, right? So when we multiply exponents, or when we multiply terms with exponents, we add the exponents. So this will be 25 x1 to the 4th over 4, right? And you'll be able to see how we can kind of just rearrange stuff and get x1 by itself, right? Definitely, you're going to need a calculator for that. But once you find x1, you'll be able to find x2, right? And from there, we know that the substitution effect is going to be a minus b. Income effect is b minus c, or a2b, b2c, a2c, right? And so if we have every point, which we'll be able to do, that'll kind of be what our numerical values for the substitution and income effect are, right? I apologize for like the kind of brutal numbers that I gave in that problem, but were there any like confusions about it conceptually? I know that I didn't come up with a final answer, but that's kind of just because of the general nature of like the complicated numbers that we were dealing with. But are there any questions about the steps that I took?
For point B, where did you plug in the 5x1 over 2?
The 5x1 over 2 gets plugged into the utility function right here.
Okay.
Right, this gets plugged in right here because we know what this is equal to. It's equal to whatever this whole mess is. Oh yeah, whoops. So even then, the exponent here is 5, so this is just, I don't know, 50 times 50 to the 5th over 7 to the 5th, right? And so either way, you're going to need a calculator. But yeah, James made an observation that the exponent here should be 5 for x2, and he's correct. Yeah, and I apologize for taking so much time, but you guys are definitely free to go. I'm going to shift rooms and move to my drop-in hours. So I believe that's a different link. So you guys are more than free to kind of go and travel there if you want. Otherwise, I'll see you guys maybe Tuesday, maybe Thursday, but we won't have group on Wednesday. So yeah.